This is called part 2, functional dependency. What is functional dependency? We will explain in this slide. Functional dependency means a relationship that exists between two attributes. For example, the relationship is here nothing but one table is called the relation. When one attribute uniquely determines another attribute is known as functional dependency. For example, student ID is uniquely determined. Say each student have unique ID. So student ID identifying what? Student name, maybe student specialization or student address, whatever it may be. That is called the things. So let X and Y be two attributes of the relation R. The student table, relationship student, X and Y, maybe student ID, student name, or two attributes. Each value of X can be determined the value of Y uniquely. That it means Y is functionally dependent on X. So what we say, generally we key identifier we say as X and one arrow mark and Y. This way we represent. The attribute of X is said to be determinant and Y as a dependent. The functional dependency classified based on the attributes: fully functional dependency, partial functional dependency, and transitive functional dependency. X and Y is said to be fully dependent when X, if Y, it does not depend on any other proper set of X. We will explain the next slide. This is just a definition. So the partial dependency is nothing but the functional dependency X and Y is said to be partial dependency if Y is also dependent on any other proper subset of X. A subset, the student subset is student name, student age, student address, student phone number, student email, if all are subset of student ID. So transitive dependencies, if X and Y is a functional dependency and Y and Z is a functional dependency, then X and Z is said to be a transitive dependency. For example, the lecturer taking course, the course is taken by what? Student. So lecturer is related to that student based on the course, like that. So X is lecturer, Y is course, maybe you take, and this course is taken by student, Z is student. So X is what? Teacher or lecturer is related to that student because of that course handling. So this is called transitive dependency, indirectly formed 2 or 3 functional dependency. This we see practically how we are doing in the next slide. This side we can see the functional dependency diagram. This is a diagram. It will be represent what? It will be represented as a rectangle. All attributes we write as a rectangle. Generally all key attributes are together. So you can say nearby. Then only the formation of diagrams will be very neater. And arrow mark indicating the direction of the dependency. For example, here what is this one? Actually course code, student ID. You see student ID comma course code, arrow mark. It shows what? Marks. First one we see. This is called full dependency. Functional dependency means if I remove student ID, this course, this mark, whose mark? So we need student. This student, this course, this is a mark. Suppose I remove course code. The student mark, which course he got this mark? Correct or not? So both this key, both this composite primary key, generally we say composite primary key, the both this one you can see this is fully dependent upon this attributes. So that's why this is called full functional dependency. Partial dependency means the student ID and student CA. Student ID, here the key identifier. Key identifier there is no arrow mark, you can see here. And then you can give what? This is partially subset, student name, student age. So the student ID is a major one, key, correct, student ID comma student name. And transitive dependency, here what they say, student taking lecturer, lecturer is related to lecturer name, like that. So this is called. So how many things we can write like this? Here you can see this is 2 and another one lecturer ID, lecturer name, lecturer ID comma lecturer. This is, you can see transitive, this one. And student ID and lecturer, here another one is there. What is it? Course code, course name, lecturer ID, lecturer name. So this many things we can write in the functional dependency. This is a diagram, this is a way you should draw and you can represent. All arrow mark is showing how it is depending upon this particular